Hello Algebra 2 students, this video is going to be a refresher over how to complete the square. Completing the square is helpful if you have to convert from standard form to vertex form. The equation we're giving here, f of x equals x squared plus 8x minus 1, is in standard form. The reason we can tell that is because the formula is written in the format of the x squared term is first. So my a here in this problem is going to be 1. The x term is second, so my b is 8. And the numbers are here at the end. That's the minus 1. So when it's in that format, we call that standard form. When we want to get it into vertex form has ax minus h squared plus k. That's what vertex form should look like in the end when we finish this problem. So to rearrange it, we are going to complete the square. So the first thing we want to do is we are looking at the first two terms and we are asking ourselves, is there anything that can go into 1 and 8 besides 1? And only 1 can go into 1 and 8. So we are ready to complete the square. To complete the square, we are going to take the number that is in front of x, and we're going to half it, meaning divide by 2, which is 4, and then we are going to square it, which is 16. That number we are going to add in the parentheses, because that makes that into a perfect square. Whatever I add here, oh, and I forgot to bring down my negative 1, I have to subtract at the end. That way, these two numbers should always add up to 0. They could cancel each other out. So I'm not changing the equation any. I'm just making it so that this part right here can be a perfect square. So now let's rewrite that as a perfect square. And this perfect square is x plus 4. Because you see, I could multiply out x plus 4. And I would get this original equation again. X times x is x squared. 4x and 4x gives me the 8x. And 4 times 4 gives me the 16. So that's how that would multiply out. So that's that part. The last part is I need to combine my numbers here at the end. Negative 1 and negative 16 combine to be negative 17. So now my equation is in vertex form. I can see my vertex here is the h and k. So it would be negative 4, negative 17. Remember, I'm always going to change the sign because there is a minus here in front of the h. So it's always going to be the opposite sign for h, and then the k will just be whatever k is. So my vertex is negative 4, 17. While we're talking about the h and k, let's go ahead and talk about the other features of that equation. So this is my vertex form of the equation. There's lots of things that are important to know about this equation. First, let's talk about the a. The a does two things to the graph. The first thing is if my a is negative here, that is going to reflect the graph. And what I mean by that is whatever my graph is, it's always going to be flipped upside down. So anytime it's negative up front, you already know that you're looking for a graph that is reflected down over the x-axis. The other thing that a can do is it can either vertically stretch or compress. And if it stretches, my a is going to be anything greater than 1. So like 2, 3, 4, it's going to stretch that graph skinnier. All right, I'll stretch it like that. If my number is less than 1, so like a half, a third, a fourth, think fractions, it's going to make a wider graph. It's going to compress it down. So those are things, the transformations the a does. So anytime you see a number in that position of the a, you know it's going to be compressed. So let's give an example. If I have y equals negative 2 x squared, for example, I know the negative is going to reflect it down, so it's going to be down, and the 2 is going to stretch it skinnier. So my graph is going to look something like that. Remember that when we're comparing our graph, we're always comparing it to the standard y equals x squared. So if you put both of them in the y equals, you could compare the two to see what transformations took place. All right, so let's talk about the h. The h is always going to shift the graph left and right. It's going to be a horizontal shift. And because of this minus sign here, it actually moves in the opposite direction of what you would expect. So for example, if you see in your equation x plus 3, let's say that was the equation, because it's plus 3, you kind of would imagine it's moving to the right. But because of that minus, like I said, it's always going to move in the opposite direction of what you would expect. So it's actually going to be shifted to the left 3. There's going to be my new vertex. And it's going to be a parabola like that. So just keep in mind that the h moves the opposite direction of what you think. Now the k is the one that shifts the graph up and down. So this one is going to shift the vertex up and down, and it goes just like you'd expect. So if you have an equation that's x squared plus 4, for example, it would shift the graph up 4, and there would be your new vertex. So h and k are both very helpful because h and k are the vertex. No matter what points in here, like if you see this one, my vertex is at -3, 0. Here, my vertex is at 0, 4. So always pay attention to those h and k because it helps you find where the vertex is at, a very critical point when we're graphing parabolas. And that's it for the transformations. Just be careful that you put those in the y equals and double check to make sure that you got everything in there right, and you should do great on this section.